Hi guys, thanks for tuning in, and I hope you continue to subscribe and press the like button at the end of the video. Would be really great. Thanks guys. Today I want to look at probability, and more so in terms of tree diagram. Last week we looked at probability with drawing up a Venn diagram, but today I would like to go over and have a look at what a tree diagram might look like, a typical example of what you might get on a NAPLAN exam, for example. What I've got is, I've got a scenario here where I've got, let's say we've got 4 red balls, and let's say we have 5 blue balls. Okay, so already we can see that we've got a total of 9 balls, and actually I'll get another colour. We've got a total of 9 balls. Okay, that's our total. Now let's draw this, let's represent this on a tree diagram. Now let's say, for example, if we chose a scenario where we had 2 events where we pick 1 ball from one event, and then we replace the ball and we have a second event. So in other words, we've got a replaced ball scenario. Okay, replaced ball scenario. All right, so if we have a look at this, one, let's say we take that. Okay, that's our first event. So event number 1. Right, event number 1. And let's say, for example, this is the red ball and this is the blue ball. So now the probability of picking a red ball is simply, we've got 4 red balls, but we've got a total of 9. So it's going to be 4 divided by 9. Okay. So it's 4 over 9. Now, what's really important to realize is that this branch plus this branch must total 1. Must total 1. So that means 4 over 9 is the probability of this one, of the red balls, and there's a probability of 5 over 9. So 5 over 9 is the probability of getting a ball on the first event. So that does equal 1. 5 over 9 plus 4 over 9 is equal to 1. So that's correct. Okay, guys, just to make sure that you're aware that this branch must total 1 in each of the events. So let's say, for example, we're going into event number 2. So let's say, oh sorry, actually let me do another color. Let's say, for example, this is our second event. Second event. Yeah. So this is, so even if I write it down here, so this is event number 2. Okay, this is the first event where we took out 1 ball, but remember we're replacing that ball. This is, so we're now, once we've taken that ball out, we're going to throw it back into the bag or into the bowl, and we're going to choose another ball in event number 2. So if we're putting the ball back, we actually haven't changed anything. We still have a total of 9 balls. Okay, so if this one here is, say, red, and this one here is also going to be red, this one is going to be blue, and this one is going to be blue. So what we actually have is the probabilities are going to be the same in both events, because we are replacing the ball. So it's going to be 4 over 9 in that one, and this is also, sorry, we'll do this one, 4 over 9 in this one, and then we've got 5 over 9 in this one, and we're going to have 5 over 9 in this one, and we're going to have 4 over 9 in this event. So what I like to do is, let's say for example we wanted the probability, let's say we wanted, just as an example, just trying to get my colours here, sorry guys, let's say we wanted to work out the probability of choosing the same colours, okay, same colour balls, okay. So, and we're picking one from one event, and we're picking another one from the second event. So we're picking it in, picking a ball 2 times, one event and the second event. So the probability of picking the same balls, what I like to do is I like to follow this line all the way through. So I just want to say red, red. This is how I like to do it, and then I follow this one through. This one is a red, and a blue. This one along there is a blue, and a red, and then this one along here is a blue, and a blue, blue and a blue. And what I like to do is I like to actually put the probabilities in there. So let's say we already know the question is asking for the probability of the same colours, same colour balls. Well, there's 2 same colour balls, so we've got a probability of 4 over 9. Oh, sorry, do that in as a 4 over 9. 4 over 9 times 4 over 9. Okay, that's equal to 4 4s are 16. 16 divided by 16 divided by 9 9s are 81. Okay, and if we have a look at another coloured balls, we have the same colours here, blue and a blue. It's not going to be either of these ones because that's a blue and a red, and that's a red and a blue, so they're not the same colour. So probability is here, so is equal to 5 over 9 times 5 over 9, okay, which is equal to 5 5s are 25 divided by 9 9s are 81. 25 over 81. But the question is now asking, the question is now asking for the probability of the same colours. So the probability of the same colour is going to be 16 over 81 plus 25 over 81 plus 25 over 81, which is equal to 81, 2, 3, 4, that's 41 over 81. Okay, that's the probability of choosing the same colour after 2 picks of the balls. Hope that helps you with your tree diagrams. On the next one, what I'll do is I'll go through a similar scenario, but one where we are not replacing the ball, and we'll see how it changes the events or the probabilities in the second event. That's all, guys, and please keep subscribing, and thanks for your likes. Keep pressing your likes, and please send us some comments as well too. Thanks, guys. Bye.